Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
This is Catherine Tucker, who is visiting us from the distant reaches of MIT's Sloan School of Business. And I think this will be a really perfect talk for this lab. Since I've been here, discussions about privacy have been some of the most interesting ones that I've listened to, because there are so many people here who have such diverse perspectives on privacy. And given that she's the only people who maybe had less of an interest in that were the biology people, but they're interested in this as well, because this is about medical privacy and not another type of privacy. So I really think this is a great example of something that spans the interests of the labs, and hopefully we'll get a lively discussion. Take it away, Catherine.
Oh, well, thank you very much. So when I was invited here today, I probably wrestled what a lot of your speakers, were wrestling with. Should I have sort of greatest hits or present a paper? And I thought usually it goes best if you present a paper. But I should just mention, I've done work on surveillance, privacy and advertising markets. And so I'm just highlighting that should we run out of things to say about this paper in advance. So this is joint work with Amalia Miller, who is a health economist at the University of Virginia. And what we're going to ask in this paper is what kind of privacy protections encourage or discourage the spread of personalized medicine. Now, it seems like a straightforward research question, but I just want to get us all on the same page about what these terms make. So what I'll do is, first of all, take you through what I mean by personalized medicine, and then talk you through what I mean when I say different kinds of privacy protections. Okay, so what is personalized medicine? It's basically using someone's genetic medicine to, first of all, understand their likely susceptibility to a disease, understanding how bad or how long the disease is going to be if it happens, and also understanding how different courses of treatment might affect how effective they may be. And indeed, if you're one of these people who worries about the cost of healthcare in the US, this seems like to be an obvious avenue to go down. Craig Venter, I've got a quote from him here saying that drugs in general only work on about 30% of the population, and that variation can often be explained by the underlying differences in genetics. Now, obviously, he is not a disinterested party. We're going to talk a bit about how effective these treatments really are, but that's the underlying idea. So I give you that idea, and people sort of think they know what I mean, but I always find it helpful to put it, also sort of show this picture, remind you that of recent news story, which is Angelina Jolie had this kind of personalized medicine when she took a genetic test which revealed she had a BRCA1 mutation, which meant she was very likely to get breast and ovarian cancer. As a result, she had a double mastectomy and a hysterectomy. So we sort of see there the potential for personalized medicine, right? We find out you're likely to get this disease, and if it happens, it's likely to kill you, and you can take action, though it tends to be somewhat dramatic often and somewhat more severe than we might recommend to the average person. Okay, so that's the basic idea behind personalized medicine and genetic testing. My next question for the audience is, who has actually done a 23andMe test? Ooh, 3 people. Your head. Okay, wonderful. So we've got two who actually, this is their job. And you, is this your job too? No, this was just fun. That's just for fun. Okay, so I do have to ask this because of the talk and where we are. How much time did you think about the privacy implications of taking that test? Not very long. Okay, interesting, interesting. Well, we'll sort of call you out on that late decision to not worry about the privacy implications later on. You're worried?
I decided there is no privacy in the world anymore, so it doesn't matter.
Oh, such nihilism from someone so young. Oh. Okay, so anyway, the reason I'm saying this is, look, we're in this room. Dare I say it, we've got some of the most sort of tech, geeky, advanced, we're in Cambridge, all of these kind of things, right? We know the Human Genome Project finished in 2003. Why haven't we also done this, these kind of tests? Well, first of all, the questions over efficacy, which I imagine you know very well, and there's sort of two different questions over efficacy. One is really how the very preliminary kind of data mining we've done at the moment, how informative or practical or predictive it really is. And the other second part of this is that sometimes there's some diseases where we probably do know about genetic markers, such as Huntington disease, where if you find out you've got them, it's not really quite clear what you're going to do from a medical perspective, apart from go out and buy the best life insurance you can, right? So there were sort of these twin questions. First of all, how reliable is it? And there were also lots of questions over what really can we do if we find out from your genetic matter what you're going to die of. The second thing, so clinician education. I made potentially the mistake of giving this talk in the Cleveland Clinic. Very senior doctors there, they were just all laughing at the idea that this could be at all important or relevant, given relative to their expertise. And you know, this is not unusual for many healthcare technologies when we're trying to think about the spread of it. Clinician education and changing opinion leaders and how they do practice tends to be a big barrier. So I don't think that's unusual. Reimbursement, of course, for all these reasons. We're not seeing reimbursement. In general, though, these are pretty common questions for any kind of new healthcare technique. What I'm going to be focusing on this talk are the patient privacy concerns. So I want to sort of highlight these exist, but focus on this talk on the idea that different kinds of privacy concerns may also be limiting the spread of these tests, though not to you. Great. So let's sort of set up this framework for privacy protections. And in general, there's something about genetic matter or or creating a digital record of your human genome, which evokes great privacy concerns. And so to just give you an example, I actually did the 23andMe test. And I found out, you know, if you believe this or not, that the data or not, that I have got a far, far higher, by orders of magnitude, chance of having macular degeneration later in my life. Now, I can say that because I'm a 10-year professor at MIT, and what really can they do? He's like, no, she shouldn't say that, but maybe I shouldn't. But, you know, you know, if you're trying to figure someone who can say that in public, maybe I'm in a reasonably privileged position. But but it sort of brings up these issues. First of all, you know, we can actually find potentially information which may have damaging implications for our employability. And what's more, the implications for employability aren't now. It's not how we sort of think about privacy protections when it comes to advertising. Instead, all the privacy implications are in a world 20 to 30 years down the line. And maybe while you're shaking the head is by that time MIT won't exist and, you know, we'll be all replaced by MOOCs. I don't know. Anyway, okay. Okay.
Where you can be forced to disclose it?
So that's exactly what I'm going to be studying, where the restrictions on how far this information can be shared encourage people to take these tests.
Can the fact that you've taken the test, regardless of whether what you find out, be disclosed currently? Like, can you be forced? Like, can someone know that you have taken the test even if you don't know?
Okay.
Is that presumably
Okay.
just as problematic?
That is a really interesting point. I'll show you some of the text of some of the disclosure documents. When I've read the laws, they fail to make that distinction. And usually the laws are around an idea of a genetic record rather than the existence of a genetic record. So I think my answer at this point is regulation is not up to your level of iterative thinking right now.
Yeah. I mean, there's an even higher level of iterative thinking, which is that the even existence of this as a cheap possibility could lead to the infringement of people's privacy and be a reason why we might want to regulate people's ability to do this at all.
So there are going to be some laws which people who sort of share your concerns have tried to implement. And some states have taken steps to have a law which says if you're an employer, for example, you can't use this information in making hiring decisions. I'm going to show you that from the consumer perspective, maybe because these laws are not well understood, they're not going to make much of a difference. Okay, so again, just before we get to sort of more data, because it's going to be very much a data piece, I just wanted to highlight that, as everyone knows, privacy concerns are not just unique to genetics. Instead, we probably have, and this is, I will want to be clear in oversimplification. In general, we have three very different approaches, potentially, I think, from an intellectual point of view, in terms of regulating privacy. And the first we might think of as an informed consent. This has been the approach very much promoted by the OECD and the EU in their original EU privacy directives, with the idea that one way we should think about privacy is regulating how people know, what people know about how their data is going to be used, so that when they consent, they know what they're consenting to. There's going to be regulating data use, and again, this is sort of stylized, but often in the US, we've taken this approach to thinking about regulating privacy. Think about credit reporting and so on. And thirdly, this sort of the more personal economics approach, which is saying, well, maybe one way of sort of thinking about privacy is that we have an absence of property rights, and as a result, perhaps what we're missing here is sort of clarity over property rights. Now, you'll notice that I put lots of question marks here. And the reason I did that is because I sort of try to say one's a bit like the EU, one's a bit like the US, and one's a bit economist fantasyland. And I did this, and then I was actually presenting this work in France. And the government people there wanted to make very clear that France does everything, right? They will do everything to protect privacy. And that I shouldn't just say that they do one thing. They're going to regulate privacy, to infinity. So take this as a very stylized idea. But what's going to be nice about this genetic setting is that because states don't know how to regulate this kind of data, we're going to see attempts to do all three in different combinations. And that's going to give us maybe more of a, an interesting laboratory, I hate to sort of say, to try and think, well, how do different privacy regulations work? Okay, last thing to say before we get on to the regression work is that, and this is why I'm sort of taking perhaps more to an argument which is familiar to the biologists here, is this question of why on earth are we treating genetic data as something special and private or somehow privileged. And this is an argument, dominated, I think, by, some jurisprudence scholars. And the argument is, well, should we think that genetic data even needs any special protections? I thought there were some kind of convincing arguments. There's a sort of genetic information uniquely powerful argument, and then there's the idea that once you do it, it's going to be created forever. Say with advertising, right? I can have been bankrupt once, search for bankruptcy once. It might be very different in 10 years' time. With genetic data, it's going to be the same genetic code, basically. And I think the other sort of good argument for me is the implications for family members, right? What happens if me talking about my macular degeneration leads people to sort of look at my sister and say, ooh, maybe her eyesight's going to go too. The other, having said that, still be balanced. Really, is genetic information, that data, different or much more severe from regular medical data? I mean, I challenge you to sort of think, well, is it really worse to have your genetic code out there relative to, say, having a positive HIV test? That's not quite clear to me. And I think in general, it's just sort of an air of we don't really know what this is yet. Should we be teaching it as exceptional before we actually know? So all of this sort of introduction is actually going to lead me to a more refined version of my initial research question, which is what we're going to do is I'm going to look to see what kind of privacy protections, and this is going to be at the US state level, encourage or discourage the spread of hospital genetic testing for cancer. And why am I focusing on hospital genetic testing for cancer rather than sort of more mainstream, broad-brush genomic tests? Well, because here, this is an area where you actually have the potential for effective and useful treatments. So, for example, as in the Angelina Jolie case, if you're found to having genetic susceptibility to cancer, there are drastic actions you can take, such as the removal of potentially cancerous tissue, preventative radiation therapy, these kind of things. So there isn't a sort of lingering doubt about what do we actually do with this information. I think I can actually sort of say this is probably a useful test potentially to take. And we're going to add to it the sort of general set of questions. Do we really see any different from attempts to regulate genetic privacy relative to the regulation in general of health data? Is there any evidence in the data for these genetic exceptionalism arguments, or are consumers perceiving it as somehow different and needing different protections? So that's where we're going. Any questions or clarity before we go into numbers? So if not, let's go into numbers and start looking at these privacy laws, because what you're about to see is incredibly straightforward, standard, reduced form policy evaluation work. So Greg's already nodding. He knows where this is going. Okay, so it's very... As I say, I was not making up when I said that states have been playing around with genetic privacy regulations, right? Ever since the Human Genome Project and, was conceived, states have been thinking about how to regulate this. They've introduced different laws at different times. There have been a few states where we've seen the law actually change over time, and they've done this in different combinations. And so that's going to be the variation in the data I'm going to exploit. We have tried, of course, because this is reduced form econometric work, you're immediately going to be asking yourself, well, is that really exogenous? Can we believe that this is not just reflective of underlying state characteristics? I'm going to try and present some reassuring evidence. We dug into why these laws happen. What you tend to find is there's one state senator somewhere who gets a bee in his bonnet. So I think we're sort of worrying more about systematic variation of that senator rather than something more systematic. That seems to be the origin of most of these laws. So those states have not yet regulated state privacy. In 2008, which is going to be part of my data period, the federal government's going to come in and provide some very baseline protections. And so I think that preempted some of those, maybe the smaller states, from acting.
Can I ask something?
Of course.
What is the difference when I go to the doctor and they recommend a genetic test for cancer as opposed to having a biopsy? What is the difference there? What extra is being revealed about me if I take the genetic test?
Ooh.
Why would I be concerned about my
Privacy. Okay, so if we're having a biopsy, in some ways it's going to tell you whether you have cancer right now.
Yes.
Whereas if I do a genetic test, we're going to find out about your likelihood of developing cancer later in life.
I see. So this is the Angelina Jolie case.
Yeah. So basically the difference is, so if you get a biopsy of cancer, you're going to go straight to start radiation treatment. For genetic test, you're going to start removing cancerous tissue probably if you have a positive result. Okay, so the source of data is going to be a series of three NIH, so CDC, basically surveys, which are part of a broader survey they do on cancer patients and cancer treatment. And in 3 years, 2000, 2005, 2010, which fortuitously overlay these periods where states were experimenting with these different laws, they're going to ask questions about genetic testing. But you should see right away from a data point of view, we're going to have a repeated cross-section, and so you should have that in mind. Now, they have quite a few data, 34 responses in general, so we have some sample size, and being a CDC effort, they oversample from people who might get cancer and then try and correct that with weights. And so all the results I'm going to report to you are based on weights, the rated results. So I think the great thing about this data is, first of all, it actually asks about genetic tests, and it does so in a representative, large national sample. The big negative for me, and maybe some of you won't have any sympathy with this at all, but as someone who usually works on questions of electronic commerce, I found it incredibly difficult to have to go to this locked room, already know what regressions I'm going to run, give the code in, and then, have everything scrutinized. I guess the good thing from your point of view is that I'm not being selective about my regressions, right? So I don't want to complain. So I think, the other good thing is that they were asking about the testing of actionable type of cancers, which is good from sort of, trying to say whether or not we care about the results. The big con, and I want to emphasize this, I can't do anything about it, is the state of the technology. Not so many people are taking these genetic tests, right? Think about this room writ large with fewer people studying 23andMe. We have sort of one person in the room. There's not that many people. And so we're just going to be dealing with fractions of percentage point in 2000. It's going to rise a little bit by 2010. But the way you should think about all these results is that this is a very early stage of this technology. And therefore, we'll talk about it a little bit later, but it's not quite clear how anything generalizes. Sort of like, another pro and con. As I say, we're looking at hospitals because we wanted a test where we could say positively this is probably a good thing to spread. The con is, in the broader world, maybe we're interested in questions of firms like 23andMe, and we don't have any data on that. Okay, and the other nice thing about this data set is we're going to at least know a lot about the people in it. They collect a lot of other controls, which we're going to use to control for all the general things you might think would affect the decision to take a genetic test.
How should I think about this process? So it's, I talked to my GP, and he said maybe I should get a genetic test given my family background, and then I go into hospital, or I'm trying to work out how much of this is about individuals making decisions and doctors making decisions.
Okay, so I've got some data which is going to help for this. The decision to actually take the test, and the reason that privacy policies are going to be relevant, is that before you take any one of these tests, for whatever reason, you're going to have something they call genetic counseling, where someone is going to walk you through the implications and the privacy policy in detail that your data is going to be stored under. Now, you're exactly right, and I'll show you some results, that there's going to be a lot of factors, including probably the doctor, knowledge of these tests, general education, which are going to affect the decision, as you'd expect. But I'm sort of looking at that intervention midway.
And genetic testing is a thing that's been around the whole time, even though laws are changing. So in 2000, as I said, in 2003, the genome was mapped. This was the first part they basically did, and it's the reason I like to study. It feels like a reasonable dependent variable, is that there've been enough articles for you to think that this is actually predictive of the fact that you're going to get cancer if you have one of these gene mutations they're testing for. Ooh.
Are you talking about sort of just testing BRCA1, like very targeted genes, versus like the whole genome?
Oh,
and these are very different privacy concerns, and they're quite different.
Okay.
So this is where, this will be my explanation. You can maybe translate it into medical terms. Okay. So the focus of these tests and the result they are focusing on is going to be for specific gene mutations. The issue then comes that you have your digital genetic matter is now going to be part of the record, even if they haven't specifically tried to correlate it with any outcome or not.
It's like sometimes people get a targeted like BRCA1, BRCA2 test, and they literally don't know the rest of the genome. And in other cases, they measure the whole genome, but only look at part of it.
So it's the latter that we should think about, I think is happening. From what I understand from the doctors, that's what is happening here.
Just sequencing BRCA genes.
It's a
1,000 times more expensive to sequence the whole genome.
Right, but I think most are. I'm not sure, but I would have thought that most of the tests in these old, especially in the previous years, like most people aren't being sequenced until now in clinical practice, like kind of this year, last year. So 5 years ago, I would imagine most of these actually was not most of the genome actually, like was not even measured. Do you know, like is that in there or?
So again, I am going to go with what I was told, which over the course of the last 10 years, one's ability to measure and understand what we see in the sequence has increased, obviously exponentially. However, the fact that the data was created in whatever year doesn't mean you couldn't go retrospectively.
If it was created, I guess
Yes.
that's the question.
So that's what I understand it is being created, perhaps because, as you were saying, because of these cost concerns. At least that's what I was told from these
It's
things.
going to be like targeted BRCA1 and 2, probably Sanger sequencing. So there are 2 genes, right?
Yeah.
There are 20,000 genes in the genome. The sequence data will be generated for like 2 of them. And the other 20,000 or so genes will not be assayed most of the time. It's much more expensive, and that wasn't even practical in 2003. Human genome, the first full genome was sequenced in 2003. BRCA mutations as a cause of breast cancer were discovered about 1990.
Mm-hmm. Yeah, I mean, I think I'll show you some of the consent policies, right? The way they're written would at least give a patient to understand that it's not just the specific mutation which has been analyzed, but instead the entire data is being stored. Interesting. Good point. Excellent. Okay. So let's go to some sort of general summary statistics. And part of it sort of goes to Greg's question. Only 43% of these people have even heard of genetic tests, right? Let me tell you, that's actually going to be a very influential factor in whether you have one, though not as determinative as you might think.
Which time point is this?
So this is going from 2000 to 2010.
Okay, but there are 3 separate.
There's 2000. We got a.
This is
This is just an average across the data.
I imagine the herd of genetic testing will change a lot.
Yeah, I mean, we can sort of, you can sort of think of the standard deviation potentially as measuring that over time. We sort of can guess the direction. The other thing I want you to sort of look at is that these think of these as being the proportions of these different kind of laws. And you can see that there's going to be different degrees of variation. Certainly the most popular is going to be the kind of anti-discrimination law or barring a employer or life insurance company from ever using this kind of data. Okay, good. So let's go to the econometric analysis, and as promised, it's going to be relatively straightforward. We are going to simply report results from a linear probability model, though this generalizes, of course, for more appropriate functional forms. But it's easier to understand a linear probability model. So the dependent variable is whether or not the patient gets a genetic test in that time period if they live in a state. We are going to relate that to the genetic privacy policy, which was in effect in that state at that time. Whether or not there was a more general health privacy policy specific to that state and the time over people's medical records, and all these sort of demographics and also the state characteristics which you might think could affect the legal regime that's in the state at that time. So sort of think of the regression as that, and of course we have state and fixed effects for these 3 years. Okay, so let's go to these initial results. And I'm just going to ask, how easily can you see this table? Because I have a bigger version, people at the back. Okay, we're okay, good. Okay, we'll just sort of walk through then the big table. And let's just sort of focus, this is where we sort of look at it separately, but let's focus on this, which is when you run them all together and reflect the fact that a state can have different sort of permutations or combinations of different laws. So what you're going to see there is that the genetic consent law, this giving people information about how their data is going to be used potentially, has a negative effect on people's decision to have a test. And let's be clear, it's a reasonably large negative effect. The anti-discrimination law, which has been at the forefront of all federal policy, has absolutely no measurable statistical effect. Redisclosure laws, that's what I call some more property rights approach, where the patient is actually told that this data will not be redisclosed to anyone without your permission. That is going to have a positive effect on the decision to have a law. And it was such a beautiful table. Hello. There we go, wonderful. To the rescue, wonderful.
Like you're really like one of these, superheroes you called in any.
That is just amazing, right? Usually it would be this uneasy.
You know what it was? The surge strip down here wasn't powered on.
Well, I have a question.
Of course.
What are the 5 columns?
Oh, so the 5 columns basically is where we look at the effect of any one aspect of a law in isolation. And so you can what you will see there is that in general you see that these consent regulations has a negative effect. And we don't measure too much precisely for the other ones in combination. And then when we get to the final column, what you see is that the positive effect we see from redisclosure happens only really in combination with consent laws. That's what you can infer from this. That if you give people information about how their data is going to be used potentially, giving them control over the chain of custody of that data, that's when we see the positive effect.
Do you have an interaction term?
So we don't have.
And we're back.
Is that, I wouldn't interpret it the way you just interpreted it unless it's an interaction.
Yeah. So.
I would interpret it is
Okay.
that these things are correlated with each other.
Yeah.
Have offsetting effects, and that only once you control for the correlation do you see the partial effect.
Right.
One holding
So
back.
that is maybe. That is, I think, exactly the right way of thinking of column 5.
Yeah.
I try to tease it apart with interaction effects. So think of this as a simplified form which sort of tells that story, right? Good. What you see in general, the other persistent result in general you get is sort of having a baseline health privacy law in place seems to have a positive effect on the decision to have a genetic test. So if we go and look at the other variables, they are somewhat as you might expect. Or maybe in some sense, maybe there's also surprises about what is not statistically significant. But being a female really matters. That's what you might expect given the efficacy of the different genetic tests for different cancers. Being black seems to have a significant effect, which may again reflect pre-existing genetic dispositions or perceived vulnerability to cancer diagnosis. Having no insurance weakly has a negative effect. But in general, one thing I'll say for the economists is that we were expecting, given the state of the literature, for insurance regime or the insurance to have a far bigger effect than it did. because all the economic models in this space have been thinking about the implications of genetic data for insurance choices. And instead, what we're really just measuring is a small, weak effect of having no insurance. Yes?
Is there a way to account for how many of these tests are subsidized by the companies that offer them? So in cases where people are saying, yes, I'll take the test, are they also getting counseling that says that, upwards of 80% or some percent of the income?
So the best we're going to get from the survey data we have is just really this question about your insurance. And I think you can we assume that never happens with no insurance. But one thing which surprised me is that maybe it doesn't surprise more economists, but we don't see the positive effect from having private insurance. And the omitted variable here, which I guess is more weakly positive, is having some kind of government-sponsored insurance. Yes?
So do you think about these laws having an effect because it's specifically about genetics, or is it just an added transaction cost? Like, let's say, I have to send in this thing, and whenever I send in biological materials, some states have a law that requires me to fill in a special export form, and that sort of is cumbersome, and so I don't do it.
Okay. So we're going to actually I'm going to try and give you some evidence on that, in that I think most of the transaction costs, who's going to bear them? It's going to be the hospital. And that's going to influence the decision of the hospital to even be offering or promoting these tests. And I'm going to run these same regressions looking at hospitals' decisions to give genetic tests in a few slides' time. But I think that's exactly right, because that's a sort of alternative explanation which is not consumer or patient-centric. Yes?
The sense of these numbers, I see lots of zeros things.
Yeah. So
would it have been shocking to see the first digit after the decimal point being 1? Or?
It would be hugely shocking, because remember the dependent variable here is 0.005. I'm almost worried that some of these numbers are too big. And if I can sort of translate this, what we're seeing here, and which is why I'm worried about it, though I'm going to present you some reassuring evidence later on, is that this bump is nearly equivalent to the positive shock that Angelina Jolie going around talking about these tests had on the national rate.
Catherine, I would run this as a baseline specification in logs rather than as in a linear probability model.
This is just a linear probability
because
model.
The thing is that that's going to approximate what a logit's going to look like anyway, and it's going to be easier for people to interpret because then its percent increases.
Okay, maybe we could do. I think we could probably do that.
Baseline specification.
Yeah, no, we could definitely do that. Yeah.
So what's
Yeah, because I think one issue is we've got such a small dependent variable. This looks small, whereas I'm wearing it so big.
50% more likely to take the test?
So that's roughly what we're seeing from this baseline specification.
Stars statistical significance? Or?
Yes, so I should have said this. So in a footnote to the table. So think of that as 3 stars is 1%, 2 stars is 5% in economics language. And then because we're not biased statisticians, we give ourselves 10%, which is 1 star. Yes?
Can you tell us, maybe out of curiosity, what is the variation in the adoption of these laws? Do states adopt all 4 of them at once, or states get the first one and then they don't get the other one, or?
Okay, so where we see, I'll tell you, where we see most states have some kind of anti-discrimination law. And one of the reasons they're going to have that, especially towards the end of this period, is because the federal government's going to do something. The main variation we see is very experiments and changes in whether you just have informed consent or whether you combine that with some degree of disclosure control.
So the first and the third.
Yeah, so that's, I think, where most of the variation is coming from. And that might be some reason why you think having statistical insignificance for anti-discrimination, you could explain that maybe we could have more variation in the data. Okay, any more questions? Good, okay. Okay, so I think I said all this in words. One thing I should have highlighted, because I think it was sort of buried, is that nothing we sort of measured at the state level seem to affect average state level effects. Okay, so this, being a typical paper of this type, we are going to do a lot of robustness checks, using different ways of parameterizing the controls. One thing we're going to worry about is exactly how you code this change in federal law we're going to do that too, and we're going to do some functional form things rather than linear probability model, though we haven't tried that idea. I think it's a good one. And nothing much changes. So I'll show you. Nothing much really changes. But I think more interesting is this question of sort of what really are we hypothesizing could be going on to explain seeing these effects, which seem large in sort of certainly incremental terms. So I think I'm going to make my argument based on actually showing you some of these consent forms that people would go and see during these sort of genetic testing, this counseling. And we're going to start off, these aren't the best examples, but they're different sort of types of genetic testing consent forms. And I want to highlight to you this particular one and this language, which is what I would say is an example of pure consent style of work. And you say, by my signature below, I hereby consent to Perker-Elman Genetics and its responsible delegated institutions or repositories to use and disclose my individually identifiable medical information, including without limitation all genetic information, right? Whether or not, and that's one of the, you remember I was saying, the way they phrase it in these consent forms isn't particular to the particular tests that you've just had. For purposes of my diagnosis and treatment, to seek payment from third parties, and to conduct ongoing healthcare operations, administrative oversight, quality assurance control, and technical innovations. Right. So I would challenge you to think really of what this statement is actually prohibiting in terms of the future use of these genetic data. Instead, the wording seems to be designed to give as much wiggle room as possible. Right.
Does it give permission to give it to third parties, like insurance, say life insurers? That not for the purposes of getting a reimbursement or payment?
Okay. So again, how would you sort of think of a responsible delegated institution?
I mean,
Again, it seems to me, I think often the wording these things is loose enough that it's not quite clear. When you say an associates, who does that really mean, right? So I think there's sort of a lot of wiggle room is often baked into these things. And I just want to sort of compare this with the wording you might see in a consent form, which actually gives you some degree of property rights, where you'd have a statement which would say the test results will be communicated to me by my physician or genetic counselor in a confidential manner and will not be released to another party without my signed consent unless required by law, right? So a far more definitive statement, which potentially gives, I think, a greater perception of control.
Excuse me, how are the privacy forms presented to the people who are going to do this? Somebody walks them through it, or is it, here's a stack of papers just like anything else, and I'm going in for my MRI, I just sign off?
Yeah, no, it's so this is a little bit different in that they do have these genetic counseling sessions where they devote half an hour to walking you through these forms. Now, the extent to which they do a good job, I have no information, but it's not the case you're just sort of walking up to the reception desk and being presented these forms. They're really sort of trying to make sure, they're at least meant to be trying to make sure you understand. Okay, so it's a slightly unusual, actually, privacy context, right? Because usually when we sort of examine privacy policies, it's far more of the sort of just tick the box, get this out of the way. But here they're actually trying to explain them. Yes?
Here they're saying it's going to become part of your medical genetic record, which then, what happens to it?
No, I think that seems true, right? I mean, what I would say is that I think all of us can see potential negative consequences still from this statement. But does it feel better than the first statement? Yes, it feels better. So I sort of think there's a feeling better, more control, rather than necessarily being a complete contract, shall we say.
There's
Yes?
also a lot of negative consequences to this sort of statement with regard to research. Diagnosing familial breast cancer from BRCA sequence is actually still really hard. And there are all these companies that do it, and they have their own case control data sets all completely siloed. And they sort of want to keep them siloed for selfish business interests. And they sort of hide behind these sometimes as an excuse. So there's a little gray there as well.
Yeah, no, I mean, I think So here, in the first one I showed you, you can definitely see technical innovations perhaps being encompassed there, that it's going to go on and be part of one of these data silos potentially. As an aside, it might seem contradictory given this paper. We're trying to write another paper at the moment which is arguing that we're going too far because we're so worried about companies at 23andMe that we're not allowing legitimate researchers to actually look at these kind of data. But I think it's a concern, and certainly this kind of blanket statement would make it hard to actually use the record for medical research purposes. But for a patient, perhaps that's a reassuring idea. Okay, now this goes back to the transaction cost question, which I think was exactly right. Which is, so I've just sort of given you my thesis of what's going on, which is that people are made to read these forms, and that one set of forms sort of emphasize your powerlessness and all the bad things that can happen, and then there's another set of forms which give you more of a sense of control. However, there could be something else entirely different going on, which is more of a transaction cost. That these regulations are going to impose different costs on hospitals, and maybe that can just explain the effect. And we're not really seeing any consumer differences. Instead, it's just an artifact of hospital availability.
Can I ask, how should I think about the people doing the testing? Is the hospitals doing the testing, the hospitals subcontracting, or the consent forms coming from people they contract with?
Okay. So what we're measuring is a genetic testing facility localized within a hospital. That's this kind of genetic testing, and all the counseling tends to take place in the hospital. I'm sure maybe they offshore it to save on costs, I'm not sure. But most of the operations, procedures, diagnosis, counseling is taking place in the hospital.
So these consent forms are going to be hospital specific?
Yeah. Yes?
But it doesn't have to work through the hospital. It could just be that, if you ask me to fill in 5 forms, I'm not going to do it. It's just, I don't want to bother with it.
I mean,
what form it is, it could be some form that I have to call, say that, whatever.
Yeah. I mean, I think my only answer for that, if it was really the case that just more paper is just off-putting, I don't have such a good explanation about why we see the positive effects from giving people more control. Right. I mean, I think you could sort of think of it as giving a baseline negative effect, perhaps, but I can't explain the positive effect. So I'll just show you quickly this regression. And this is where we run the same regression, but we've entirely changed the data set in the background and changed what the dependent variable is. And the dependent variable is now going to be whether an individual hospital has embraced a genetic testing facility. And this is, we're using American Hospital Association data here, or whether a hospital system potentially has adopted this kind of genetic testing facility. And we're going to use the same variation in laws. And what we're going to find is the same negative effect from consent. And so that suggests that rather than it just being the sort of powerlessness I was suggesting, I think part of the result is going to be some kind of transaction cost explanation, that having this extra sort of burden of getting consent and so on is going to be off-putting to a hospital because you're going to have the legal expertise and a parallel system and ways of storing all of these kind of things. What I want you to notice, though, is that we don't have any positive effects anymore, though, from this redisclosure law. And if anything, it seems to be slightly negative. And that might be, for the reasons you suggest, why might I have a genetic testing facility? Potentially because then I can draw researchers to my hospital, use this data, become famous, all these kind of things. And the genetic with disclosure law sort of stops that process. Now, it isn't significant, so I'm entirely just sort of interpolating from a statistically insignificant coefficient, but it's interesting it's in a different direction. So I think, the main thing I have against the redisclosure part, at least being an artifact of transaction costs, is that we're not seeing it having the sort of, we're not seeing sort of any effects on hospital decision. That seems instead to be working through on the patient side. Though certainly the consent law does seem to have some negative effects on hospitals' decisions. And if you sort of compare coefficient to coefficient and sort of do some back-of-the-envelope calculations, it's probably explaining at least half of the effect the hospitals are put off from adopting these systems. Yes?
Couldn't there be some sort of feedback where the hospital is less likely because it thinks the patients are less likely to say yes?
Yeah, no, I mean, and this is very reduced form with absolutely, and, because one thing I'm always asked is, well, why don't you combine these? And it's precisely because I don't want to sort of overstate how much we can sort of tease apart about what's driving the two decisions. I don't really have any instruments here. Yeah.
What do the baseline rates look like for hospitals adopting genetic testing facilities? I mean,
I should have that statistic there. From memory, it's around 20% here.
20%. And can you do, so in the other regressions I mentioned, you can't.
Yeah. Oh, sorry, it's lower than that. So it's like, I got that wrong. It's around 8%. I'm sorry, that was my mistake.
Okay.
Yeah.
Can you do sort of pre-trend sort of testing here? I wonder, you might have enough.
Yeah, I mean, I think that's exactly right. And we've tried to do it for our free data points. It always just looks a little bit pathetic. If it takes long enough to publish the paper, maybe we'll have 2015, and then we'll, have at least 4. But no, I think certainly one drawback is the usual things you'd like to see in a paper like this, like pre-trend. Yeah. We can't go back further because, these tests didn't really exist. And I guess we can just wait a long time to get published, right? That's the only other solution. Quite good at that, though. Yes?
So I'm trying to remember what the state of the BRCA testing business was in like 2003 or 2010. If I recall correctly, there was a single company, Myriad Genetics, that had a patent on these 2 genes. Mm-hmm. So this patent was struck down by the Supreme Court.
Yeah.
But so how much of this is which hospitals choosing whether to offer tests, and how much of this is like this one company deciding where to send its salespeople?
Oh. Okay, so that's really interesting. Obviously, we're going to capture that sort of baseline change with Heidi Williams has done wonderful work sort of studying the effects of that. We're going to capture that with the year effects to a certain extent.
I think that was after your period of data.
Yeah, I'm just trying to.
Okay.
Yeah, I'm just also. You say that, I'm wondering if it's some kind of instrument I could be using here. It could be possibly.
Do their sales data.
Of course, they're about to do that. Or maybe you could have some kind of home-based locational advantage or something like that. I'm not sure. I don't know if you remember those figures, but at the beginning, at 2000, we were at 0.04, 0.4%. By the end, we're at 0.6%. It suggests to me that they had a stranglehold. If you're right and they had a stranglehold at the beginning, we haven't seen even too much entry during this period, right? It's not the case. There's been this huge increase since the beginning of the period.
Since the Supreme Court case in 2013.
Yeah.
Your data end in 2010, right?
It ends in 2010. So that's, again, interesting. Yeah. Again, you see, everyone's saying don't ever publish. Get some more instruments. You can actually maybe identify some of these things separately. Good. Okay. I've got 10 minutes left. And it's 10 minutes, right?
Yes.
Yeah, okay. So the rest of the paper is, I always sort of say it tongue-in-cheek, then goes exactly in the way you would expect an economics reduced form paper to do, in that we're going to show there's absolutely no effect where you wouldn't expect it, and there is a stronger effect where you'd expect a stronger effect. So what we did, first of all, was sort of worry a bit about these state laws, we think they're sort of driven by individual state legislators, but what if there are other things going on in the state which can explain them, and also explain changes in genetic testing rates. And we were worried about 2 things, or at least we identified 2 things. First thing, maybe they reflect something about underlying health privacy, or taste for health privacy. And so what we did was we used a dependent variable, which is whether or not you've ever had an HIV test, and saw, how was that influenced by these different genetic laws? And we showed that when you have non-genetic data,
I'm going to actually propose that if you're willing, that you spend the last 10 minutes talking about other things you're interested in on privacy, and what else interests you beyond this. rather than going into sort of like, all
the usual things.
checks, because
That's fine.
I just think for this audience, it'll be perfect.
Okay, good. Well, as I say, if you are a reduced form econometrician, all the stuff is there you'd expect. We have the falsification checks. We also show it's going to be, you're not going to see an effect for people who've already had cancer because the bad news is out. And we're going to show these effects are strongest for people who have the biggest potential of having bad news from the test. So, as I say, this is sort of a study of health privacy information. The first one, at least, to try and do something like this about individual decision-making and relating it to state laws. And what we find is that giving over people control actually seems to have a positive effect on decision-making. And this is particularly so for people who are worried about bad news. On the other hand, our typical of, very, I think, legalistic approach, which is informed consent, we see a deterrence effect at both the patient level and the hospital level. And all these sort of data usage policies, which has been the big focus of government policy, end up having absolutely no effect. And whether that's good news or bad news depends on your prior about how damaging most regulation is. Okay. So I think Glenn wants me to sort of get here to sort of think about, well, where is this all going, right? And why do I think it's important? Well, it's important because I think there's a far broader set of questions which take us away from our focus on thinking about advertising and privacy, about thinking about, well, how do we regulate for future selves, that is a self for 10, 20 years ahead, given the persistence of digital data and our lack of ability about how to think about the technology. Okay, so that's sort of general thesis, and one way you could sort of think of this question as being motivated is that in my prior research, I looked a lot at advertising privacy, with work I'm very proud on, and I continued, I think I have in retrospect, been somewhat frustrated that so much of the policy debate has focused on privacy concerns relating to advertising, simply because the short-term news is a short-term effect. Maybe it's overt, maybe it's off-putting, maybe it's creepy at the time, but there don't seem to be the more negative long-term consequences of digital data. And so this was an attempt to sort of start to think, well, what's the real sort of privacy concern I have deeply as an economist? It's, well, we're now creating a permanent digital record of ourselves, something we've never really experienced before. How do we regulate for that? And so it's sort of trying to go where I thought the harm was most severe. The other piece of work that I'd like to highlight, just because it's something that someone actually at Microsoft Research in Cambridge has also thought about, is government surveillance. And this is, again, an attempt to try and move the discussion away from privacy and advertising to think about other ways we might worry about the digital future and privacy. And in this research, what we do is we look to see how the Edward Snowden revelations affected people's behavior on Google Trends. And it's a very, very simple paper. You might think this was complex econometrics. Let me tell you, we get even more simple there. It's really all bar charts. And what we show in that paper is that, in general, in the US, the changes in searches you see are really simply on words which might mark you out as a terrorist. So people stop searching on anthrax, they stop searching on pipe bomb. Right, we definitely see that. So it seems in some sense a reasonably rational response. On the other hand, internationally, that is, and this is internationally has been defined as US's top 10 trading partners. What we find there is that searches, yes, you still get people searching a bit less for pipe bomb, but instead we see a drop in searches for a far more personal kind of privacy protection, in that we see people stopping searching on anorexia, stopping searching on various medical conditions, stopping searching on bankruptcy, all these kind of things we might think of as personally embarrassing rather than just stuff that will give us in trouble for the with federal development. And so based on these results, we then draw a rather grandiose policy conclusion, which is that, well, we often think of surveillance as just simply being, something for our political scientist friends to worry about, but actually potentially commercial economic effects from various governments' surveillance policies. So that's some sort of other work I wanted to highlight. And I'm highlighting it just simply because I know there's been a researcher at Microsoft, and he actually looked at just US data and didn't find much. And I think, he's using Bing where there's actually market share, so it sort of makes sense, right? You look at the US. But it does make sense to me, given that most of the effects we saw were actually internationally, where perhaps sort of you have to use Google data. Okay, Glenn, was that what you were wanting me to do?
I'm just interested where are you, like what other stuff are you doing on privacy? What's your agenda on this?
She can't tell you.
So I think, as an economist, you always sort of I always try and step aside from being too grandiose about my ambitions. But I think, the two papers I've described as typical of where I'm going now, which is trying to think, well, are there areas that perhaps we've studied less, which might matter more in the future? So that would be my sort of grand statement of where I'm going.
Okay, great. Well, thanks, Catherine.
Thank you very much.
Question.
Of course.
Have you thought about or looked at all maybe adoption? So genetic information is a substitute in a way for knowing your family history. Have you looked at controlling for how well people know their own family history?
Well, that's a really nice idea. The furthest we got is that if you have a family history with bad cancer in it, the effects of the laws tend to be more pronounced, presumably because you're more worried about that you're going to have a bad test result. But we just don't have the data adoption, but that's such a cool idea. Really cool idea.
Actually allow people to go and continue speaking.
Great. Wonderful, of course.
Reception.